All right, so we have probably 3 or 4 specific environmental issues that we're going to talk about over the next couple of days. We'll start today with acid rain. Has anyone heard of that before?
Yeah.
I think some people have. Now, acid rain is also called acid precipitation because it's not just rain necessarily. It might be snow, okay, sleet that is acidic as well. And it's not really what you think probably. Some people hear that term acid rain and they think, well, if you walk outside during a time when it's acid rain, it's going to like burn your skin and burn a hole in your umbrella and stuff like that. That's not the case. So acid, when we say an acid, I think you guys sort of understand what that means, but acidity is like a property of matter. Just like you can measure the temperature of water or another substance, you can measure what we call the pH of that substance. And pH is a measurement of how acidic it is. The pH scale goes from 0 to 14. Right in the middle, 7 is what we call neutral. Like pure water is a pH of 7, it's neutral. Things that have a lower pH, we call them acidic. Lemon juice is slightly acidic. Orange juice, coffee, vinegar. Battery acid is a strong acid. And so that's what pH means. pH is a scale, and a lower pH number is more acidic. Usually rain in unpolluted conditions has a pH of about 5.6, so slightly acidic because of carbon dioxide that's mixed with the water. That's normal rain. But when cars, factories, power plants burn certain fuels, fossil fuels, they can release sulfur or nitrogen into the air. And that sulfur combines with water and forms sulfuric acid. And that brings the pH of the rain lower, making it more acidic. And then that rain falls to the earth, and it can do damage to ecosystems. Some ecosystems can't tolerate acidic conditions. Certain lakes, certain types of forests, certain animals can't survive under acidic conditions. And so when this pollution forms acid rain, right, it can lead to ecosystems being damaged, being destroyed. Often lakes are affected by this, especially northern lakes like around us, the Adirondacks. If you imagine all winter long as snow builds up throughout the winter, if that snow is acidic because of pollution, when it suddenly melts in the spring and all that melted snow goes into a lake, it can cause its pH to drop very quickly. And that can lead to damage to organisms that live there. There are some lakes where there's basically nothing living in them because they've become so acidic, nothing can really survive there. They're called dead lakes. It affects forests with certain types of soil that can't tolerate it, that can't buffer the pH changes. And acid rain was once a bigger problem than it is today. Because we have some new technologies that help to remove some of the sulfur from the exhaust produced, we've improved upon this problem somewhat. But you look at this map, the orange areas show areas in which acid rain is more of a problem. And so where do you find us on this map? Is our area affected, Jordan? Where are we? Yeah, we are in some of the worst areas in terms of acid rain. Okay? These orange areas show the lowest pHs. And there's a reason for that. And if you ever follow like the weather or storms that move across the country, or weather patterns, in the United States, most of our weather and most of our prevailing winds go from west to east across the country. When there's a big storm in the Midwest, that means often a couple days later we're going to have a big storm because these winds move in this direction. Well, they also take pollution. There are areas like here in the Midwest where there are factories that burn these high sulfur coal, and they have very, very tall smokestacks, go really high into the air. So they release all that pollution very high in the atmosphere, and then these prevailing winds sort of take it and bring it to the east and drop it on our area. So, like if New York State, for example, passed some laws regulating the amount of sulfur in our emissions, really might not even help us very much, because much of that pollution is coming in from other areas. This, is there one more slide? I wanted to show you. This slide shows some of the effects of acid rain. Okay? Here you see a forest, a spruce forest in Maine. And spruce trees can be really affected by these acidic conditions. And so here you see all these trees have died because of these acidic rains that have been making the ecosystem more acidic. Here you can see tree rings that show the age of the tree, and they've gotten smaller each year because of the lack of growth because of this. It also affects sort of statues and stuff. Like, I don't know, people thought I was weird when I asked this. Did anyone ever like walk around a cemetery and like look at the old gravestones and stuff like that? No? One person, two people? Kind of interesting, I think. But anyway, if you ever been in a cemetery and you see the really old, like whitish colored gravestones, and often you can't read the writing, that's because those used to be made out of limestone. And limestone interacts with acid rain, and it gets worn away very quickly. That's why, like on this statue, this is a photograph taken in 1908, and then the same exact statue in 1968. Basically, all of the features have been worn away because of this acid rain. See, this statue's been damaged by it as well. Usually moss or mold or stuff like that. All right, so I want to show you, go back here to this slide and show you this video. This is a little bit about acid rain, because we used to hear a lot about this a while ago, and this is sort of talks a little bit about how acid rain has changed more recently.
I finally figured it out. Prince must have been singing about acid rain that was blue, because carbonic acid turns litmus paper red. Blue plus red equals purple. You know what I'm singing about up here? Come on. Hey there, pH Balance friends. Trace here for D-News. If you were to compare environmental issues to fashion trends, I mean, why wouldn't you? Then acid rain would be the equivalent of bell-bottom jeans. People started talking about it in the 60s, and it slowly infiltrated media and pop culture, and by the mid-1970s, seemingly everyone had an opinion on it. But since then, where did it go? To understand acid rain, you have to understand pH levels. pH means power of hydrogen. Essentially, it measures the kind of hydrogen in a solution. It's not super important to understand how it works, but it ranges from 0 to 14, with 0, battery acid, being the most acidic, and 14, lye, being super alkaline or basic. 7 is neutral. Water is 7. Milk is 6. Seawater is 9. A change in even one number is a big deal because pH is measured logarithmically. One number represents a 10-fold change. Okay, so acid rain is bad, you guys, like really bad. It toxifies lakes and streams, destroys forests, and threatens entire plant populations. Acid rain is even harmful to urban environments where it eats away at limestone and marble buildings, all because its pH is crazy. I say crazy because normal rain is acidic, just a little bit. As rain falls from the sky, it picks up carbon dioxide in the air, creating carbonic acid. This gives natural rain a pH of about 6, just slightly on the acid side, similar to urine or saliva. Regular rain becomes acid rain when it picks up not just the carbon dioxide, but sulfur dioxide and nitrogen oxide, which contain much stronger acids. These make their way into our atmosphere when we burn fossil fuels to make energy. Once natural rain picks up this acid, its pH can drop as low as 3. That means that rain goes from pH 6 to pH 3. It's 1,000 times more acidic. 3s are things like citrus, kimchi, or soda. The effect of acid rain entirely depends on where it lands. For instance, if it falls on limestone-rich soil, it doesn't have much of an effect, because limestone is naturally alkaline. It has a pH above 7. So mixing acidity with a lower pH just neutralizes it. In fact, to protect cultivated areas from acid rain damage, limestone can be added to soil as a sort of pH balancing fertilizer. Though that's pretty much out of the question for huge tracts of land in the wilderness. When acid rain falls on natural or acidic soil or on vegetation, that's when things get bad. Living things have a hard time in acidic environments because the acid basically kills their growth enzymes. Fish can't swim in orange juice. What's more, hydrogen ions in the acid rain replace nutrients in the soil, like calcium and magnesium, which are vital for plant growth. This is why we preserve things in vinegar rather than water, because the acid in the vinegar prevents pickles, or kimchi for all you foodies, from growing mold. Keep in mind that we're talking about ecosystems, so everything is connected. Once acid rain infiltrates soil, it flows into streams and lakes, killing marine life. Even water-dwelling animals that can live in acidic environments, like frogs, still end up dying because the acid kills their food sources. This sort of environmental damage stems as far back as the Industrial Revolution. However, the public didn't really catch wind of it until the 1970s, after it had already caused massive damage, which is why you heard about it. Why you don't anymore is because in the early 1990s, the US government passed a series of regulations that dramatically reduced sulfur dioxide emissions, and acid rain sort of fell off the radar, at least in the US. Acid rain is still an issue in China and Russia, two countries with lots of factories and few environmental regulations. China is particularly bad as its coal contains higher than normal levels of sulfur. Even parts of Eastern Europe, Canada, and the United States still have rainwater that's just too acidic. And even though our rain will likely never return to a 1960s level of acidity, the effects of this environmental disaster will exist for decades. If you're still mad about acid rain, why don't you make a website and tell people about it? No domain extension will help you tell your story like a .com or .net domain name. And because you watch DNews, you can get 15% off domain.com's names and web hosting by using the code DNews when you check out. So, acid rain is still a problem. But what about that hole in the ozone layer? Whatever happened to that? You can find out in this video right here. Ozone is 3 oxygen atoms linked together, O3. When in the stratosphere, ozone absorbs harmful UVB radiation, protecting us and other life here on the ground in the troposphere. Should we do a whole video about pH? That's kind of cool, right? Do you have other science questions? Tell us in the comments. Make sure you subscribe so you get the answers. And thanks for tuning in to DNews.
All right, so you see there, the U.S. has done some work to address the issue of acid rain, but other countries still need to do their part as well. All right, so let's talk a little bit about another issue, smog. So smog is another type of air pollution. Smog is a portmanteau, a word combined by smushing together 2 words. Smog comes from smoke and fog. And smog is a type of pollution that happens when emissions from cars or factories interacts with sunlight and forms basically a gas, ozone gas, that's very bad for living things. This toxic gas can damage people's lungs, harm animals. There are some areas where smog is a major problem, areas where there's lots of cars, people drive a lot, there's factories. Also, cities that are like in a valley, because that's where like the smog sort of settles there and doesn't is not carried away by winds. If you were to live in a city where smog is a major problem, in the morning when you watch the weather report, they don't tell you just the temperature and if it's going to rain or not. Sometimes they tell you the smog index, which is a sort of indication of how much smog there is on that day. And on certain days, they will tell you do not go out and exercise today. Smog levels are too high. Because if you're out going for a run or something, you'd be inhaling a lot of that smog, and it could damage your lungs. People that have like already existing diseases, it can make them worse. Things like emphysema, asthma. And so to help improve upon this problem, basically we need to reduce the amount of these pollutants coming out of factories and cars and so forth. Now, does anyone, if you know anything about cars, there's a part in a car called the catalytic converter. Has anyone ever heard of that? If that's a part in your car and its job is as the exhaust from the engine is coming out through the tailpipe, it goes through this device, which basically burns off some of those pollutants so that less damaging stuff is coming out of the tailpipe of the car. In fact, every year, cars need to be inspected. You may know your parents bring your car to be inspected every year. And they have to test what's coming out of the tailpipe and see if it meets the standards. And if it doesn't, your car doesn't pass inspection, you can't drive it. That's to help reduce these issues of air pollution such as smog. This is an interesting picture. This is Beijing, China. Okay? Beijing has a major problem with smog, so does a city like Los Angeles, California. And this is a clear day when the winds had taken away that pollution. Here's a day when the smog had settled in the city and you can't hardly see anything. This is toxic gas. Okay? That's at ground level, that if you were walking through the streets, you'd have to breathe in to get to where you're going. So anyone ever watch, I doubt you guys would be interested, but maybe your parents, you might know this, watch the series on Netflix, The Crown. Anyone? Yeah, a few people. But The Crown, it's about Queen Elizabeth in England, and one of the episodes talks about this episode that happened in London where there was a major smog problem, and part of that series covers this, and this video is a little bit about this smog problem that happened in London. It's kind of interesting.
Hello and welcome back to another episode of A Brief History of, and today we'll be looking at the killer fog of 1952.